our discussion for today is how to find for the number of memory address given the number of bit address. Okay. At the same time, how could we complete a memory map of a certain given memory? So first and foremost, so for instance, we're given an n-bit address. Okay, so the number of memory address is equivalent to 2 raised to n, where n is the number of bit address. Okay, basically the lowest address is stated as 0 hexadecimal and the highest address is 2 raised to n minus 1. Okay? So, depende yan kung ilang bit addressing ang given dun sa ating problem. So, for instance, meron tayo ditong given a 16-bit address. Find the number of memory address. So, the number of memory address is basically equal to 2 raised to n. If n is equivalent to 16, okay, therefore, the number of memory address is basically equal to 2 raised to 16. So, by equation form or by computing it, we have here 2 raised to 16, which is equivalent to 65536 memory address. So take note, there would be 65,536 memory address possible for a 16-bit addressing. And this is basically equivalent also to 65,536 memory cell. Okay. So, ito yung ating sagot. If you are asked what would be the lowest address for this given 16-bit addressing, we have 0 ang lowest address natin. While the highest address would be equivalent to 65,536 minus 1, and that should be converted to a hexadecimal number. So, as application ng ating lowest address, determining the lowest address and highest address, we have here a memory map. Okay? So, a memory map is a graphical representation of the division of a memory into different portions. So, for instance, a system that uses 16-bit address, draw the memory map. So, for instance, we are using a 16-bit memory address for this one. And it is divided as we have a ROM having an 8 kilobytes memory, then a RAM of a 4 kilobytes memory. Okay, then this would be an open memory. Okay, we are asked to draw the memory map or to complete the starting address and the last address of this 16-bit addressing. So, since 16-bit addressing ang ginamit natin, it connote na we will be using a 64 kilobyte memory. Okay? Paano natin nakuha ang 65 or 64 kilobyte memory? From yung lecture ninyo na meron kayo dyan, wherein 1 bytes is equivalent to 2 raised to 10, or that is 1024. Okay? Since ang 16-bit addressing memory, this is the same as 2 raised to 10 multiplied by 2 raised to 6, and this is 1 kilobyte while 2 raised to 6. So, solve natin ang ating 2 raised to 6. We have 6. We have 64. Okay? So, this is equivalent to 64, while yung K natin, o eto, is the same as 1 byte. So, therefore, this would become 64 byte. Okay? So, etong buong memory map natin becomes a 64 byte. Okay? So, naintindihan. So, at that point, if ROM is divided as 8 byte and RAM is divided as 4 byte, how many would be the open memory? Okay, so that would become 64 minus the 8 kilobyte minus the 4 kilobyte becomes the open memory. But if we are asked to complete for the lowest address and the highest address of each of this memory, paano natin siya hahanapin? Okay? So, the memory capacity is equivalent to the last address minus the starting address plus 1. So, ano itong memory capacity natin? Say for instance, itong buong system, ang memory capacity natin is 64 kilobytes. Okay? Pero if we are going to consider only the ROM, ang memory capacity ng ROM is 8 bytes. And RAM is 4 kilobytes. So, identifying the starting and the last address, dito yung ating last address, ito yung starting address natin, automatic ang starting address natin is 0. Hexadecimal. And the last address would be equivalent to the highest address na meron tayo. Okay? So, consider the 64 byte system. Okay? What would be the last address? So, since memory capacity is 64 bytes, is equal to last address, yan muna yung unknown natin, then minus the starting address which is 0 plus 1. Therefore, convert natin to into a memory address. This is the same as 65,536 is equal to the last address minus 0 plus 1. So, last address is equivalent to 65,536 minus 1. So, 65535. This is in decimal form. What we need here is a value in hexadecimal. So, madali na lang po yan. So, gagamitin natin ang mode setting na 4. So, decimal po siya. So, 65535. Convert natin yan into hexadecimal. So, we have a value FFF. So, 4 na F ang equivalent niya in hexadecimal. So, therefore, the last address here is F, 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 F. This is if we are going to consider the whole system. So, therefore, gawin lang natin ang maging consistent. This is 0, 0, 0, hexadecimal. Okay? But, if we are going to consider, so consider natin ang ating 8 kilobytes. Okay? So, that means 8 kilobyte is equal to last address minus the starting address plus 1. So, 8 kilobyte times in 1 kilobyte equal to 1024 equals last address minus 0, which is yun, plus 1. So, para consistent, lahat dapat ng values natin is naka-decimal muna. So, therefore, tuloy natin, that would become k-byte, cancel out. We have 8 times 1024 equals last address minus 0 plus 1. Last address considering the 8 kilobytes is equivalent to 8 times 1024 minus 1. So, what would be the value? So, decimal muna tayo. Decimal. So, 8 times 1024 minus 1 is 8191. Convert natin yan sa hexadecimal. That is the same as 1F. F. F. Okay. So, the last address here is 1F. F. F. So, mag plus 1 lang tayo. That would be the starting address of the open memory. Plus 1 is equal to 2000. And, pwede natin gamitin etong part na yan para kuhanin ang last address ng open memory. Para mag plus 1 ulit tayo to get the starting address of the 4 kilobytes. Pero, kung ito ay consider natin. Okay? So, again, consider natin yung value na yan. Consider the 4 kilobytes. So, 4 kilobytes, which is the memory capacity, equals last address minus the starting address plus 1. So 4K byte times in 1K byte, 1024. Okay? Equals, since ito ang kino-consider natin, meron na yung last address, ang hahanapin na lang natin is starting address. Okay? And since ito, ang FFF is the same as 65,535 in decimal. Therefore, yun ang gagamitin ko. So, 65535 minus the starting address plus 1. So, starting address is equivalent to, okay, interchange ko lang, 65,535 plus 1. Then, ito, maka-cancel out, minus 4 times 10, 24. Is equal to, so ang value natin dyan is in decimal form. Decimal natin, 65535 plus 1 minus 4 times 10, 24. Value is 61440. Convert natin yan sa hexadecimal. That is the same as F000. So, starting address for this one is F000. Mag-minus tayo ng isa, that will be the last address of the open memory. So, mag-minus tayo ng isa, that would be E, F, F, F. So, that means, this would be the solution of the memory map of a 16-bit address. This would complete the memory map. Starting address, last address of 8K byte ROM, starting address, last address of the open memory, and this would be the starting address and the last address of the RAM memory. So, take note of how to complete the memory map of a certain given addressing. Hope you've learned from this video.